Okay. I assume we're live. This is the Fireside on Re-Decentralization, which we'll get to in a minute, offered by the networking channel. Um, Thanks to our sponsors up above. Next slide, please. Today's panelists, John is the Marconi Professor at the University of Cambridge. I thought it was a great choice to pick Marconi. He's one of the more interesting people in history, John. Paul Mockapetris. I'm known for being the inventor of the DNS. And that's what we're going to talk about today. But before we get to that, we have previews from the next meeting of the networking channel. Next slide, please. Which is going to be a fireside chat with Brian Idelson, Chief Ecosystem Officer at Zoom. And we could learn perhaps how this all works. Jim Kuros will be leading that discussion. But maybe we should get to the meat of the event, which is re-decentralization. And John, perhaps you could tell me what your view of re-decentralization is.
Yeah, sure. Well, there's a bit of history where I get to name check you, and then there's so the internet was conceived at least partly from the Paul Baran report, which suggested that a defensible system or survivable system would go on working even if you broke as many components as were just short of disconnecting things. So that has to really run in a way that doesn't have a central command and control, because that becomes a massive target. And then once it's broken, things stop working completely. So IP routing, or routing, as some people say, was inherently distributed, and about a decade after the first IP routing, we had to connect multiple management domains, and we used a technical federation. So the BGP or EGP, but BGP later was federated. And then we got fed up with having lists of IP addresses that we had to remember. So somebody came up with this system of domain names, and the domain name system, which you are the inventor of, is somewhat decentralized. I'd say it's distributed and federated, but not fully decentralized. But certainly there's no single authority. That's the nice thing. You completely locally add things. There's a structure which has some central agreement, but and then obviously Berners-Lee came along a few years after that and created the World Wide Web, and in a similar way, web servers do not have to be approved by anyone centrally. You start up a web server on your host, and other people may link to it. You may link to them, but that's up to you. One of the things that at that point, around 92, people have been working on hypermedia systems, assumed that if you added a node in a hypermedia network, you would have to add bidirectional links. And they thought that Berners-Lee was mad, but they were wrong, because the whole point about scaling these systems, scale out and deployment, works because you didn't have to coordinate. You had a coordination tree system, and that you can add coordination later. So if you get kind of 10 years after the DNS and you end up with search. And search could be distributed, could be decentralized, in fact, and there are some systems out there that do that. But what happened with search was, after a few attempts at searching the web, Page and Brin came up with PageRank, and as a side effect of PageRank, they created a centralized index which is used to compute the PageRank of a given page. How often is it got in links from lots of other places, which is kind of a proxy for popularity. But they also observed that then meant that they could figure out what was going on with advertising on web pages, and they could figure out how to charge for advertising by going through click-through, counting number of clicks. So they then get effectively a combination of how important is a page and how relevant is it to people, but also how much people actually act on that relevance, at least in terms of accessing information. And that became a central point of charging and making a lot of money out of the whole internet. And then since then, 25 years later, we've seen the emergence of centralized AIs, which also crawl all the data in the web to train a large language model, and then have a centrally owned large language model, whether it's OpenAI's ChatGPT or GPT 345, wherever we're up to, or it's Gemini from Google or whatever. And the centralized system is then a huge money-making exercise, piggybacking off all the hard work everyone did with adding content in the internet. In a decentralized system where the IP routing is still distributed, where the name system is still distributed, and where the websites are all distributed, but all that information is then brought to some central points and then exploited. And so the re-decentralization is to say, well, maybe we should go back to some of those clever inventions of IP routing and the domain name system and the World Wide Web. And there are other systems like that. And think about maybe restructuring our systems so that they have the survivability property, which would be useful potentially, that attacks on a centralized service can render it completely dead, as opposed to just taking out parts of the system. But also attacks don't have to be, from the threat of a bad actor in the sense of, enemy. They can just be attacks on the ownership model. So the way that the AI training works by using everything out there in the web and all the hard work that people put in editing Wikipedia content and so on from many different sites, those that work is not recompensed, but it is exploited. There are other examples where a lot of media sites in the early days, a lot of video and audio streaming, would allow people to upload content and then ask later whether the content had a copyright owner and whether the copyright owner might be paid. And that's an interesting kind of reversal of the normal process where you go and find somebody who owns content. You say, oh, we'll pay you some money and then we'll have access to it. To be fair, the model Google, YouTube have is very much that they negotiate agreements with all the large copyright owners before they're publishing content. And then if they're allowed to, they can either give the marketing information or actual payment or actual advertising revenue to the copyright owners. So that's kind of a middle model, but they're still somewhat centralized, but there's distributed ownership going on. So but anyway, so re-decentralization is to reestablish both the structural advantage of distributed, decentralized, and federated, potentially more defensible in some ways against various threats, and possibly to go back and revisit more fair ownership models. Now, I'm not an economist, I'm not a moral philosopher, but I just have a position on that personally. I think people should be paid for what they create. I think that's reasonable, perhaps not for all of time, but up to the point they've got a reasonable repayment. But separately, I do think it's more potentially more resilient to many forms of attack, including sort of toxic content, maybe. And we've seen recent moves in social media platforms. So these are non-static content, but they're where the content relates to yourself and your relationships with other people online. And obviously, email is such a system, again, decentralized. An SMTP server doesn't require any central authority to say it's okay to run an SMTP server. You may nowadays have to pass various checks that weren't in place 50 years ago when email on the internet was first deployed. Email's a bit older than the internet, but so other social media channels, whether they're secure message platforms like WhatsApp, Signal, and so on, are somewhat centralized. But now we have decentralized versions of social media platforms like Mastodon and Blue Sky, and there are many others. I'm just picking those because I'm on both of those, and they're somewhat decentralized. You can run a Mastodon instance. You then just decide how you federate to other instances. So very much like the web or the domain name system. So that's my take. That's where I come in on it, to looking at this. And partly it's an intellectual curiosity thing. I mean, one of my positions, ignoring the moral philosophy or the economics, it's a challenge. Search was this first very centralized system, in particular the click-through advertising architecture. But doing decentralized search is actually quite a hard problem. doing decentralized social media is not a hard problem. I mean, really, like I said, email was an example of that, and it should be really, it is fairly trivial to build a system that does some kind of instant message platform that doesn't have central points of failure management control or whatever. Um, there are big challenges though. There are really big challenges, and we can talk about those. I mean, I've got a list of things I think when you do decentralization, you have a harder time solving some problems where the cloud centralized systems have an easier task to do some things. Like, I think scale out provisioning is one example, but there are lots of others that are more sort of computer science challenges. So that's my opening kind of position.
Okay, great. I've been to several workshops about decentralizing the internet. And one of the questions I always have is what's the point of maximum leverage in affecting change these days? And that could be where in the stack do you get opportunities? And it might be where you are, from a legal point of view. I'm not sure what the right answer is there. I can observe that from the last conference I was at UCLA on this subject, they were mostly talking about messaging systems. And, it seemed like at the same time they were doing it, they were also, creating the dream system for the cartel that would like to be able to share messages without being observed. So where do you think leverage is, and what's the next problem we should attack?
Yeah, that you've actually nailed one of the kind of tensions for an application like messaging systems, which is that we can build decentralized systems like decentralized email, but the opponents of such a system say, well, the problem then is for legitimate wiretap or intercept, that causes big difficulties. And particular, since the last 25 years, most applications do fairly good end-to-end encryption. The combination of end-to-end encryption and distribution with no point of legal leverage. You can't go to a company and say, I really want to look at everything you have on these people, and I have a warrant from a court that says we know for some other reason they're probably bad. We just need a bit more evidence, which is a legitimate complaint. That is a big problem. And there are solutions. I mean, even in federated systems, I mentioned one I'm involved in called Matrix, which is a it's somewhat like Mastodon or Blue Sky. You can run Matrix instances at the same kind of model like the SNTP. So we can run one of those, or you can run a Mastodon instance. But we respond. I work with the people there, and we respond to law enforcement. When the law show up and say we believe there are some bad people doing bad content on one of your servers, we go, well, it's not one of our servers. You need to talk to the people running the server because there are different servers. So, but if you've identified they're there, then you can go and talk to them. So it's a bit like you go to an ISP if there's a denial of service attack, and you backtrace to where it's coming from, and you go to the ISP and say, we need you to trace back to specific customers that may be doing a denial of service attack. And this is now in the content, the application layer. The other motive for federating systems is there are so many that it's very difficult for people to interoperate. For example, we're using Zoom right now, but if we had somebody who wasn't allowed to use Zoom for some reason, but they're on Teams, how would they talk to us? Or they're on WebEx or something else? And that's a really bizarre situation because the internet was about interoperations, and we interoperate completely different hardware. We have Wi-Fi access here, or cellular wireless access, or we have Starlink wireless access, or we have copper or fiber, or and that works. And then IP routers are built by lots of people, and switches are built by lots of people, and servers are built by many people, and they interoperate and HTTP level and TCP, maybe quick, but lots of people implement those. And then you get up to a messaging platform, and I've just had to join Zulip, and Zulip is yet another platform that's kind of a bit like Slack, and it's a bit like Mastodon, and it does a few things like Matrix. And now, if we post something on Zulip, my friends on Slack don't see it. So this is ridiculous. Whereas if I post something on a mail list on the IETF, the Internet Standards Group, working on secure message platforms, people could be on an email system that's implemented by Outlook, by Microsoft, and somebody else is on, a SendMail implementation from Lord knows why, because that would be out of date. But they could be on Fastmail. It doesn't matter. It could be on Gmail, and they completely interoperate. So that is another piece where I think the first bit of your question was, what's the downside of having these decentralized systems? And it could be law enforcement. And I think that's not necessarily a complete problem. In fact, let's give the famous example was when there were genuinely terrorists were stopped by in the US. It doesn't matter where it was, but a couple of years back, and they had been using iPhones to communicate, but they were unfortunately dead. But the feds wanted to get at their iPhone data to see if they communicated with anyone else. And Apple implement a secure end-to-end protocol, including all the backup on the iCloud. And the Fed said to Apple, well, we need to look at this, and we really, really know these are bad people. And Apple were like, well, we're really sorry, but we really, really don't have the keys. So tricky one, but that wasn't the decentralized system. So the problem happens, it can happen from decentralized, but decentralized just makes it a little bit more difficult because you have to identify the instance that somebody's on. End-to-end encryption makes it a lot more difficult. And then you have to think about key management, and that's out scope of my expertise. I believe there are ways you might discuss with people that implement these systems where in the past, governments have talked about escrowing keys so that when you do the key creation, the system is required to place copies of the key somewhere so that law enforcement can get at it. This is tricky because the people you mentioned from the very bad organization might undermine that system, get everyone's encrypted data. So that could be your banking and so on. So that would be bad. So, so that the security people say they don't like the idea of backdooring encryption or the key management because the risk is that the bad actor, who could be a state actor, not just organized crime, well, the really bad state are often run by people who look very like organized crime, but they would then exploit backdoors in the backdoors, and then we would all be in massive trouble. So I don't think there's a really good answer to that. I don't have a technical answer. It's partly policy and management, but I don't think re-decentralization is the primary cause. I think that end-to-end encryption and key management have been the big headache for the law enforcement folks. And I think they have a legitimate claim that there is an issue for them. I mean, in the end, in the Apple case, they managed to use some clever tricks to get access to the information. So, but you could imagine a system where that didn't work. So yeah, it's a tricky one.
Yeah, I could pass you a note that you could burn and then mix in your favorite acid and spread all over the continent and know the information is gone. I think that's possible, but I do wonder whether or not people should be. I mean, first of all, you mentioned the Apple platform. That's kind of centralized.
Yeah.
And the other thing is, if you have a few billion machines that are all running the same algorithm, is that centralized or not? And do we need to worry about that?
That's a really good point. We just have published a paper in a very weird conference, which is the Aarhus University has a decennial conference every 10 years. It's only once every 10 years. And we published a paper where the starting point was that we really, really need a much larger gene pool of code, of implementations of anything, whether it's central or decentralized. And I absolutely agree that if everyone had the exact same piece of code that ran a decentralized system, that any vulnerability would be available to bad actors everywhere anyway. So you wouldn't get all the gains. There would be topological attacks that would be harder, but software vulnerability exploits would be no more difficult. So actually, Mark Hanley, quite a few years ago, had a paper.
Uh-oh.
And orthogonal to whether you're central or decentral. Only having one implementation of everything, or only having two or three, is a big problem, because then when you have an exploit, it will target everything. And we've seen this even in the crypto protocols. In, I think, OpenSSH 1 year had 63 vulnerabilities, and it was being used by a large fraction of the internet for just encryption. But actually, it had, people kept finding vulnerabilities, patching it. But that's a big problem. So that's another interesting problem. It's again slightly separate from decentralization, but I think federated systems, decentralized systems, make you think a bit about it more. And they also offer a chance. For example, if we federate all the secure message platforms in the world, there is diversity. If we can make Signal talk to WhatsApp, talk to iMessage, then you've got quite a bit of diversity in the way that email systems have. After SendMail bugs were revealed, people started implementing other email systems, and then we had diversity. And I think actually, Li Zhang has just posted a chat message about using the same algorithms, different problem from vulnerability. Sure, you can have diversity of algorithms that still achieve federation. I mean, when we federate routing systems, we don't run the same IGP. That's one of the cool things that BGP did, is it let you isolate domains. Weirdly, a lot of AI data centers are running BGP, which is mysterious because only a single domain, but I think it's because they're using policy components of BGP. But anyway, the point is there are ways to federate different algorithms. And another example of that, I would claim, is in content moderation algorithms, where, for example, the Mastodon system allows you to have diverse moderation. And this is an old idea. Moderation was done on Usenet and UCP news systems way back. And again, slightly parallel to the internet, although news moved over to the internet after a while, was getting fed up with the UCP and dial-up. But you can have different moderation systems, and I think that's an example of like diversity support, which is also quite interesting, because if you don't like the moderation on one system, you can go to another, and you're not subject to that. I nearly got kicked off a Mastodon instance, actually, because I posted information about a startup, and the instance I was on was zero tolerance for anything commercial. And they weren't against commercial. They just said, we don't want that discussion. We want to talk about recipes, like the old Usenet groups of recipes. I'm like, that's great. I'm sorry, I've made a mistake. And they forgave me. It wasn't like you were kicked out immediately. But I like that diversity. It was good, and you could, so you can tolerate diversity of algorithm. I think it's interesting. Again, it's intellectually interesting to think how you construct applications which had really different structures.
Yeah, I sometimes think of centralization as being like entropy. You can't win, you can't break even, you can't get out of the game. So I guess my question to you would be sort of, what have been the big successes of re-decentralization and the big failures? Where do we take a wrong turn? Where do we take a right turn?
Well, I do think the number of users of some of these federated secure message platform and social media platforms have got hundreds of millions of users. And people say that's small compared with Meta and X and so on. But the federated system have only been around 10 times less time, and it takes a while on a logistic curve to get to a lot of users. And there's no technical performance reason why they couldn't scale to having everyone on the planet. So I think those are successes. I would count those as pretty big successes, and they're pretty usable. People enjoy using them as much as the central systems, probably more actually, because they tend to have lower toxic content. But that's a separate argument. The failures, really, I mean, we've completely failed with AI. AI, the huge forces, the companies that are building. Meta has Llama, which is they train up and they do a really nice job with that. And OpenAI has a ChatGPT system, and Google has Gemini, Anthropic have their system, and so on. But these are when I say central, they're centrally controlled, centrally managed. Of course, they're not completely central in the sense that you still have spiders and robots that crawl the web to get the content for training, and they may often only use internal data from their organization to train, which is fine. Obviously, there's no ownership issue there. If they want to do quality control, that's a good idea. But actually, the really interesting thing we saw in SIGCOMM last week in Coimbra was that quite a few papers about how you scale the training of LLMs, for example, and the data center scales that they're running at are, they're like, you know, when Paul, when you were doing the DNS, I don't remember how many computers there were on the internet, but you know, let's say there were a million. But now these folks are using single data center with 1 million cores, and you know, and 100,000 GPUs, and I think some of them may be heading for 1 million GPUs, and and so actually there's a distributed algorithm running inside the data center with its own routing infrastructure and its own, you know, fault tolerance. And like I mentioned, they're actually using, you know, BGP and multipath and all kinds of tricks for transport to make it scale to 800 gigabits is now the kind of the preferred, you know, interconnect speed. These things are crazy. They're literally like in the whole of the internet in 2000. You know, they have in a single data center in terms of the amount of data and bandwidth. But so they are distributed, but we totally failed to decentralize them. And this is kind of weird, but because actually there are a couple of examples of federated learning out there. And going back to Apple, I will cite them. They trained predictive text on the iPhone by learning what you were likely to type as the next character on everyone's phone separately, and then building the statistics of if you had typed the letters PAU, then the probability the next letter is L is very high. It's very unlikely to be X, you know, so they have a distribution of probabilities. And they then sent that distribution for everyone's phone to Apple, who then had a predictive text system, which had been trained in a federated way. And so they didn't invade your privacy when they did that. They didn't know that you had typed PAUL and I had typed PAUL, and some strange, you know, somebody in South America typed PAUX because it was a word in Inca or something. I don't know. But they just had the distributions. That federated learning is starting to take off, but there are only a few small examples at the moment. They don't go anywhere near the sort of thing you see, you know, on the sort of chat GPTs of the world or the Geminis or whatever. But they can. There's nothing to stop them going to that, you know. So then you could imagine, you know, a couple of billion laptops and phones and tablets in the world federating a model, and then everyone has access to that model. There's no central ownership, but it didn't reveal anyone's data either. And that's another example where there's a potential success, but we haven't seen success at scale. We've only seen these couple of modest examples. But I would say that the predictive text is pretty funny, because when you look at what transformers, what LLMs do, they're basically very big predictive text systems. It's just they're much bigger than predictive text for your secure message platform, you know, like iMessage or whatever. They're huge with, you know, billions of tokens rather than just a handful. But still, that argues that you really could build, and in fact, some people have started building some of those kinds of decentralized AIs and training them in a decentralized way, and then running local inference. Don't need to run decentralized inference. So I think there's sort of examples where we've failed in some cases, but we have alternatives that might take off, and we also have some alternatives that have taken off. But it's a mixed story.
All right. By the way, people out there in the audience, we have a chat going here, and if you have questions, we're going to have some time reserved for your questions. So you ought to start populating the queue, please. I have one sort of personal thing here. When I was doing the DNS, one of the things I did was set up the zone structure, which divides control over parts of the namespace. And I set it up so that, and I thought this was a virtue at the time, so it could be either one enormous database or each name could be its own separately managed thing. And you could decide, you had a free choice about doing that. People have told me that I did that wrong, because the way it's set up now, it's getting re-centralized. The re-centralized people are certainly hard at work at the DNS. Do you think what should have been done differently? I'm asking you to be my critic.
I don't actually know. I think you got the sequence of work on the DNS right, because I don't think you could have deployed something. You know, everyone wanted to do some really clever, complicated thing. Like my colleague Steve Keel was working on X500 directories, and they have certain facilities that are nicer than DNS. Like for example, you know, search but they didn't get deployed for a very long time, and even today directories are only deployed in very narrow use cases because they're infinitely more complicated. It was just too hard to make them work back then, and you know the DNS was just simple enough and no more. So I don't have any criticism of that actually, and you can go look at things uh, you know later. I don't think it's impossible to kind of, you know, we've seen various security things added to DNS in various ways. We have sort of TCP to get at the DNS. Then we have like secure, you know, things which really annoy the security agencies because now they can't even tell what you're looking up, you know, because you have HTTPS to the DNS, and they're going, oh my god, we don't know what name to address you're looking up. And it's like, yeah, so that's privacy, you know. There's a question in the Q&A actually, which is also it's kind of related but more general version of this, but I think it's a question about the centralized systems have the attraction is simplicity, and particular for the user. And this is something I really agree about. I think it's a big challenge, which is it hides something, which I think I'll just get to in a second. If you build a centralized system, you need to think about availability. And obviously, if you have something that's based in one data center and the power to the data center goes, let's say you build something in Madrid. You know, in this year in Madrid, there was the whole of Spain had a 24-hour power outage, so you would have zero access to that. So the first thing you do is you replicate, and you do state machine replication and data replication for your data center services, and you may even do, you know, live migration of services for preventive maintenance, but you also replicate, and you have replication algorithms like Paxos and Raft and so on. But they're completely hidden from the user. The user doesn't know about that. When you look up a service, you get routed to, typically at the application layer, using some rotary, load balance, or whatever front end, you get routed to the nearest one that's currently working. And then that service will have, you know, state, whether it's in memory state or storage, that's replicated by one of these algorithms. And you will present the same kind of thing. So you're buying tickets for an airline. It doesn't matter whether you're routed to something in, you know, Los Angeles or Madrid or London or Paris or whatever, or Athens, you know, that you go to that server. They have the same state of how many seats there are free on some given plane. Hopefully, some of the airlines don't seem to do this properly, but you know, the same with banking. But it's transparent to the user. So the problem with the federated system is if you offer services that involve updates, so which is most things like social media and email and so on, then you need to do that replication for availability reasons. But the scale of the replication system is now huge because you now have to figure out of billions of end systems, you know, where are the replicas and how many replicas do you need to get the same availability? And I think the single thing that stops people large scale adoption of federated systems or decentralized systems at scale is at the moment we don't have really nice libraries of functions that implement consistency, you know, state machine synchronization or whatever, that deal with, say, the kind of 6 or 10-fold replication you might need. And if you've got a federated system, why would you accept to run my server, and maybe because I run your server, why would you accept to store my data? Or maybe I store your data, but how do we choose a set of people to do that? If you're Amazon AWS and you're Microsoft Azure or you're Alibaba or whoever, you own all this infrastructure and you say, we are going to do, you know, X-fold replication, or you have a customer and you're a multi-tenant data center, they run a service, and you say, do you want 3-fold replication and do you want it geographically dispersed? And that's just a parameter for Kubernetes or whatever. And then you go, right, there you go, we're running this level, we're running this level of availability. For doing that for a decentralized system without a central agency knows where everything is, you have to build that. You have to build that service to do availability. It's just availability. Now, the questioner also asked about, you know, there's this complexity for users, and where this shows up, for example, is in Mastodon and other social media platforms, the instance you sign on to is visible in your name. This is kind of a little bit odd, except it's kind of like email, but in email, I'm Crowcroft at Gmail. This is not lucky because I was one of the first Crowcrofts to get a Gmail account. I was lucky. But why is Gmail visible? It's an email address. Why? And if I was on Hotmail or I was on, or whatever, then why is that visible? So now you have this million instance problem, which is I'm on, whatever the Mastodon instance I'm on in the Netherlands, and why is that visible? And it's really weird. And if there are millions of those, how do you find somebody? And again, now you have a huge problem, which could be solved with a search system, but now you have to build decentralized search to find people, and maybe they don't want to be found. That's okay. So there's a bunch of things you have to build where centralization makes discovery a lot easier, and it makes the management of resources for replication a lot easier. And so decentralized systems, for me, really interesting technical challenges is solving those things, is finding people and identity and privacy, the link with that, and the other is scaling availability, which is kind of ironic because I've been claiming decentralized is more available. But what I'm saying with decentralized is it's more available statistically, like the internet is more available at the IP level than the old phone system in some senses, or it's much cheaper to make it the same availability. But now we have this other kind of availability, which is content and computations, and that's a real difficult challenge. So I think this is a really nice kind of set of problems to try and figure out at scale. There is work out there using gossip protocols for consensus at scale. You can just use Raft and you can modify it to deal with asymmetry, link failure, and performance, and so on. And then somebody else has asked a related question, which is in the AI space, there are now tools that allow you to connect AIs together. So now you can actually federate AIs with MCP and A2AI. I can't remember the expansion of the acronyms, but somebody else can put that in the webinar chat. But there is hope that a lot of people are now building small models. Often they start with a medium scale model like Llama 4 is pretty decent, and then they train it up on they add layers of localization, and then great, thanks, yeah. So model context protocol and agent to agent. So those would allow you to then run lots of models and federate the models. That's slightly different than federating the learning, which I talked about earlier. So locally learning a model and federate by exchanging parameters, and everyone's copy the model. You can actually build an entire model that could be some specialized thing about, I don't know, the best predictor of places to go for Americans in London for restaurants or whatever. Could be a cool model, and it would look at you and look at what Americans did, and it's a bit like a recommender, but it could be cleverer than that. And you might federate that to some completely different model written by other people in a different way that is a recommender for places to stay or art galleries or Paris rather than London. And that will give you diversity, but also connectivity. You can also actually connect different models that model different things. So it could be well-being. Where do I go running in London before I'm going to the recommended restaurants? So I think, so there are these challenges of decentralization. I think finding things, people, and consistency are computer science problems, which we have only the beginnings of solutions, and making those work to be completely usable and transparent and retain other advantages. Tricky, really tricky. And I think we should be dealing with that. And they'll also potentially maybe are more sustainable. Now that's an argument I don't want to 100% claim, because I had a discussion with people at Amazon. In fact, Neil Lawrence, who used to be head of AI at Amazon, is in Cambridge in the same department as me now, and he said, "Well, we're not absolutely sure about that. You can do the numbers for what does it cost you to train a model, and what does it cost you to do inference on the Amazon cloud, and then you can do a decentralized one." And now I'm backing all my computations and storage on 5 other people's phones, and they have to be live to do consistency. So all the phones are on all the time. It's not clear that that's actually more efficient. So I'm not going to claim efficiency necessarily. Maybe more efficient. That will be good. Anyway, that's another aspect. Yeah. So these are really interesting technical challenges for people out there looking for 10 PhDs worth of work, I reckon.
So let me ask you a question, perhaps a little bit from left field. So in your quest for decentralization, how do you view the whole crypto space and those kind of people, there's all these different coins and exchanges of value. I think value and identity are two of the unsolved problems that we have in front of us.
Yeah, I totally agree. We've been working on a project with the Gates Foundation, actually funds some work that we're doing in how to do national digital identity systems. And the question we get asked by some countries is they don't trust their governments, that it's like a decentralized identity system. And then you have all the questions of how do the servers communicate with each other so there isn't surveillance by the government? How do users understand how to use the system? How is the key management done for users? And one of the pieces of this is a really nice thing, which I thought hadn't been solved, and somebody told me it has, which is imagine my life is on my phone. I live on a $50 Pixel 3 phone because I'm kind of strange like that. I don't believe in spending a lot of money, but it's a smartphone, it's Android, and it's got 1 year left before it runs out of security updates. So what happens if I lose my phone and it's got my my entire history of keys and passwords and passphrases and all the other technology and so on. So I have two phones that are identical because it's only $50. I can buy an identical one and I synchronize them. So I don't keep them in the same place, right? So when I'm traveling, I put one in a safe in a hotel, the other one's in my pocket, and I lose my phone, I go back to the hotel, get the other one out, and I'm back live again, and I order another one. But I don't have to do that because I could synchronize to your phone, and I can do that. There are apps on Android and iPhones that let me push the keys out to people using secret sharing. And then when I lose my phone, I can use some proof of my identity. It could be biometric, was built into me, but doesn't involve any bits, doesn't remember. I could go up to you and say, can I take your phone, present my fingerprint, my face, and maybe other factors. And then it goes, oh, right, okay, wave your new phone at me and I'll restore everything. And the other personal phone will not have access to all those keys. So that is a usability thing, which I think is a massive advance. And again, it's orthogonal to decentralization, but it's necessary for decentralization. But it's really handy, and that suggests that we can learn from some of the people that really understand privacy. And I like Apple's attitude mostly to privacy. They're not living on sort of selling your data to everyone else, which is a nice position. Other people say, fine, you can make money selling data, that's okay. But we can learn from that and say we could reapply that approach in a decentralized world for ID. But you have to root the ID somehow in the person, and then you're back down to what proves I'm me. And that's typically, in the end, it's going to be biometrics. And I'm sufficiently paranoid that the laptop I'm using and my phones are all at least fingerprint protected. So I know I could walk out of here and someone's going to cut my fingers off. I'm sure that's going to happen because there's so much valuable data they can steal from my laptop that isn't already available on the internet. But actually, going a bit further on that, biometric now is very sophisticated because most biometrics checks also do liveness checks. So you have to do behavior. So one example is you could do face recognition. The system can tell you to say a phrase. It can check your lips. It looks like somebody's saying the phrase, and your voice matches the voice and of that it's got biometric data for. And that combination of things is really hard for a deep fake AI to do in real time. It's really hard to do in front of a secure camera, and the camera channel to the processor is secured, so it's really hard to fake that out too. So actually, we have systems to re-onboard somebody. There's a beautiful protocol for re-keying as well, with a colleague of mine, Frank Stiano in Cambridge, did as part of his PhD. It was called the Resurrecting Duckling Protocol. It's like when a duckling is born, it bonds to its mother. And if the duckling dies and is resurrected through some magic ritual, it has to reestablish it's got the right duckling and right mother. And so he came up with a protocol for that. So these things can be done. Again, they add complexity. In many cases, though, we already have the complexity. We have complexity in replication in data centers already. We have complexity in key management so that if you lose your phone, you can recover even with privacy on iPhones and if you install the right stuff on Android. So we already see this. It's not the complexity isn't there. It's just that the centralized people have managed to hide it very nicely. I'm not against them doing a good job of what they do. And I'm just saying a certain advantage to decentralized, and we need to learn from those and then also figure out how to make them scale. And I think scaling is a big challenge.
Yeah, there is one comment in the Q&A from John Day about X500. I always thought that one of the reasons X500 failed is it didn't use itself to keep track of where its servers were. In other words, the first application of the DNS, everybody says, oh, it's to do internet addresses. No, it's to tell you how to find the right name server to ask. That the first query ever sent was a query about name servers. And one of the things that I was hoping to do early on was to have the DNS be about more things than addresses, so that we had to do name servers just to make the search for the right name server work. I had always hoped that email addresses could be divorced and that the right-hand side could somehow vanish. I failed at that. I think that nobody wanted to do that, first of all. Say, well, we want to manage our users' mail. And I'm saying, well, why couldn't my mail just follow me? Or why couldn't we have a layer of indirection where you'd send email to Paul Mockapetris and they'd say, oh, yes, that's really pvm@isi.edu or whatever.
Yeah, I think your point is very nice that the bootstrapping of the DNS federation is the fact that you had the name server look up before everything else. That's a really beautiful bit of computer science. It's like that's really good. And actually, it's kind of one of the things in federated systems where I don't think they some of them have systems like that as part of their architecture, but not all of them. So they haven't quite got that. When we were doing decentralized search, there's a friend of mine at Southampton University, Thanasis Tirapanis. He has a very nice project which does decentralized search, and part of that is how do we find all the people that we need to talk to do decentralized search, and you need to bootstrap that way. And yeah, I think there's a lot of it's one of these things, like I said, it's sort of make it as simple as possible and no more so. But that's a really good point about the starting point. That's really cool.
Yeah, I think that there's this whole question about how do you design systems, protocols, et cetera, in such a way that they're open to evolution and expansion. Um, and I think that's something you need to do, but on the other hand, there tends to be all these nested shell scripts and so forth that people do them, so that you've got to preserve a certain amount of order while you grow. And I don't know whether or not that's scientific or not, but it's one of the issues, I think.
Right. The other thing that kills things is again not a technical thing at all, but when you and I were first on the internet, so we're going back 45 years roughly, there were not very many people around, and we all worked at, whether you were at ISI or UST or UCLA or, there were not very many sites. And outside the US, there was, Norwegian Telecom and UCL in London and the folks in CNR, Felice in Italy and so on, that handful. And we kind of trusted each other. We didn't even think of behaving badly. For about 10 years, I don't remember there being anyone actually really behaving badly. But there's a natural thing, as a certain society gets beyond a certain scale, you don't know everyone, and you don't even know somebody who knows somebody. You don't even have, 5 degrees of separation starts to creep in, and the bad behavior creeps in. And so now you need mechanisms that scale fast. So one of the things as the system scales out, you have to scale up faster. And famously, PayPal was the first online payment company that had a fraud detection system that scaled faster than the bad actors in payment systems. All the other companies contemporary failed because fraud grew faster than their income and it overwhelmed them. And PayPal had a very neat, actually AI-based fraud detection system that actually worked very high. And your point there is that, yeah, you need to have evolution built in so you can add features as you get to a certain point. You're above the parapet, as we say. You're sticking your head up above the window, and now you're a target for somebody because they go, oh wow, you're actually big enough that we care about. Oh, you might have money, or you might have information, or something we can attack or steal or whatever. And now we have more and more interesting technical challenges. I would claim decentralization makes some of those attacks harder, and that could be that could help us take take breath and figure out some of the defenses. But on the other hand, to make them scale to existing systems, we have to solve other problems. So it's a kind of race at the moment. But the number of I don't know if you've seen, but today's news in the UK is that the Jaguar car company has shut down, and it doesn't know whether it will be able to make any cars till the end of the month, and it's told all its workforce to stay at home because they've had a big security breach. And presumably it's a ransomware attack, or I don't know what. The details are not necessarily public, but that the consequences are that there's value in attacking something once it gets to a certain scale. If the Jaguar manufacturing supply chain system was decentralized and diverse, as we were talking about earlier, had different implementations, it would be a lot harder for somebody to build that attack. Not impossible, I'm not going to claim that, but it might raise the level of the competence of the bad actor more. But yeah. The other thing with X500, by the way, to be fair to use, your code was pretty nice, and the bind implementation of Berkeley was fairly readable, whereas at least the Quipu system, which I was familiar with, was not. Even though Steve Kill and Marshall Rose were pretty good programmers, it was pretty hard to read, and there are a load of other moving parts in X500. Like you have to implement these other weird sort of CCITT protocols, which are extra complicated, including ASN.1, which is one of the world's greatest inventions that had to tie up a lot of people scratching their heads. But anyway, that's another story, sort of history lesson of how not to do some things.
Yeah, there is this question about, maybe it's textbooks is the answer, I don't know, but about how knowledge gets lost. So I can't count the number of times that I've had people come to me with something of the flavor of, oh, there's this fatal flaw in the DNS because I can create this query that causes an unbounded amount of work to be done. All right, and there's lots of different ways to do that. And there's no way to deal with that. And I said, well, actually the first implementation of the DNS, what we did is every time we did something, send a packet or whatever, we would decrement this counter, and when it went to 0, then we would throw that query away. So what we did basically is we said, okay, we will do 6 units of work per query, and when it triggers the 7th, we throw it away. And that there's still that kind of vulnerability there. One of the things I expected people to do is to add more complicated search functions to the DNS, but then you get this question about, well, okay, how do you prevent this resource exhaustion kind of attack?
Yeah.
And that's always a question in these federated models, because if you try to federate with somebody that's a bad guy, they will, just like Captain Kirk, you'll have the robot malfunction by giving it some query that can't be answered.
Yeah, I mean, I think sort of dynamic resource management. One of my colleagues has an email system which throws away email. If he hasn't looked at it within a certain amount of time, at the very least, he just tags it. Then, if he hasn't tagged it or actually read it, then it just disappears. And it's just to say, I've only got so much time, and I can only read so many emails a day, or just discard it. And people think he's unreliable. He's not. He's extremely reliable. His mail system is deliberately unreliable, so he doesn't get tied up in infinite, numbers of. Whereas I have the opposite, which is very bad and it's foolish. Actually, I answer any meaningful email, which then means I end up in discussions with everyone, which is fine because I quite enjoy it. But it's an infinite sink of time. But luckily, I still get paid, so that's okay.
Yeah. By the way, for all the attendees, there's a link here in the chat session if you want to register for the next event that's coming along. One of the events that's coming along later in this session, in this spring session, I guess it is, or whatever they call it, is looking at the real-time bidding system, which is sort of a decentralized a centralized system that decentralizes access to your private information whenever you look at a web page. It's sort of an interesting take on this. When people talk about the security of DNS and DNS lookups and so forth, I go, look, you should really take a look at how your privacy is being, it's like they're going through your wallet where you're going, aha, is there a danger in front of me? It's very bizarre. I don't know. We have time for a few last questions, but I think we're running out of time. One of the things I'll just tell you a story was that my last failed proposal was to the NSF, where I said I want to build a distributed index of the internet. And they said, oh, no, it's too big to possibly do that. At the at the time, there was maybe a couple thousand machines on the internet. What would you tell the people that sponsor research? In this case, they got it wrong. What would you tell the people that sponsor research what they should be doing in this area?
Well, the first thing is that it's important that the people that sponsor research actually have experts in the organization. So DARPA, historically, I had very good experience with, because the program managers are usually people like us who get seconded there, and NSF is similar. The EU is not bad like that. It's actually got a fairly good technical reviewing process. The UK is terrible. The UK, for some weird reason, doesn't have any technical experts in our national funding. So when you put in a proposal, they send it to random people to review. So that's the first thing. The second thing is, yeah, you just have to have a watching brief of the community, because the community, will have some consensus about what the interesting problem is, not necessarily about the best solution. And then also, computer science internet research is quite cheap. I mean, not if you want to build OpenAI's next data center, but if you want to build, a lean language model, or you want to build the weather prediction systems that we've just built in Cambridge, that are more accurate than any other weather prediction. It was not an expensive thing in computation terms. It just took clever people. So the question is, how do you tell who's clever? And then it's just that usual competition is okay. Yeah, right now, I actually put a proposal for European funding to do re-decentralization, and I got really nice reviews back from them. They really got it. So I was very impressed by their ability to recognize that they thought they agree with me. That doesn't mean I'm right, but they said this is something that somebody should work on. They didn't give me the money, but not because I was wrong. They said this is a good proposal. I think that's the thing I really liked. When I talked to the DARPA program managers, and same with NSF, you were talking to somebody you knew. I mean, there wasn't nepotism, because they're not allowed to work in the same topic ever again. So they do that job at the end of some bit of work. So they finish doing it, but they're respected by the community. I really like that model. And I've seen European Research Council has a similar model. I talked to somebody who I was on the panel for 6 years reviewing things there. And the person who managed the panel was extremely wise and informed about what the computer science and engineering people were doing. So I think that's the crucial thing. But then, who knows where the really cool idea will come out. I have no idea. Somebody's going to build a neuromorphic aquarium or something, and a fish will compute the future.
Well, thank you, John. I think you're uniquely informed and wise in this area, and thank you very much for your time. I think we're out of time. Have a good day.
Yeah, thanks very much for the session. That was a lot of fun.
All right.
Hope people got something. They can email me if they want to ask.
All right. Bye-bye, everyone.
Bye then.